Yes, it would help if I turned the microphone on, wouldn't it? Been talking to myself. Been asking Rihanna questions and she didn't answer any of them, and I was like, hey, I wonder where Rihanna's not answering my questions. Helps if I turn the microphone on. Thanks, Pragmatic. We're looking at, you thought that was by design? Yeah, could be. You can see my little icon light up when I talk, so at the top. If Rihanna's still out there, she might have left. This thing we were looking at wasn't a Cymbella, Rihanna, that was Ensynema. And the one that we have in the center right here is neither. This is an Amphora. Amphora have a sort of, well, they have sort of like this smile or mustache or banana shape. And then they have a raphe that you can see, but it's what we call an eccentric raphe. So what that means is rather than running down the middle of the valve, it runs along one edge, on the valve face still, but just on one side. And both branches of the raphe are right here. And then for amphora, what you usually will see is little tiny striae down here, and on the other side of the raphe as well. What's up?
Just gathering the garbage.
Oh. The garbage lady's here. And that's pretty much characteristics for amphora. The back of the diatom, or what we consider to be the back of the diatom, when you have asymmetric diatoms like this, the back side here is just like on a whale or a fish. We would refer to this as the dorsal margin, and this is what we would call the ventral margin, or we think of this as being the belly of the diatom. So this one's upside down for you. Actually, in the microscope, it's right side up, because everything on the camera is flipped over. And then that there is a Cyclostephanus malawiensis. There's several of them in the field of view, actually. And a little Pseudostarocyrrhopsis and a Starocyrella. Little acanthes right there, acanthidium of some type. And there's a bunch of little diatoms sort of scattered all around in here. They're slightly dissolved all over the place. I can hide that arrow for now. I think this is probably Amphora tinganike, but I'm not positive about that. This big thing that we see right here, not a diatom. This is a sponge spicule. It's made out of silica. It's not a whole sponge, it's just one of the little megascleres. Megasclere inside of a sponge. Normally there's, probably millions of them. Inside them structurally, these are microscopic components of a sponge skeleton. And you can tell that it is a sponge spicule because of this feature right here. Running right down the middle of a megasclere like this is going to be what's called an axial canal, and that feature does not occur on diatoms. And it looks like a bump on the surface because of my DIC optics, but that is in fact inside this sponge spicule. So if I do some optical dissection, you can see the outside of the sponge spicule. Now we're looking through the middle of it, and you can see it all comes into focus at roughly the same time, and then it goes back out of focus, and that's the backside of the sponge spicule. So one of the things that's kind of nice about transmitted light microscopy is we can see through things. And if you're careful with your focusing, if you use optical dissection like this, you can actually see structures on the insides of things. And that is a skill that's extremely important for diatom analysis, and pretty much for anything that has a skeleton that you're looking at inside of a light microscope. And the reason for that is, when we look at stuff at 1,000 times magnification, which is where we are currently, the depth of field is very, very small. Maybe a couple of microns at best. Hey, Jimmy James, how you doing? And so as a result, we can only have a little sliver of everything in focus at the same time. So you can see, like, now the top of the sponge spicule is out of focus, but the middle is in focus. But look at all of the things in the background are now out of focus, right? Except for the tall things. And if I put the diatoms in focus in the background back here, then our sponge spit goes out of focus. And that's because as you get closer and closer to things, the depth of field shrinks, and you can have less of it in focus at the same time. Is everything on the sample dead? Yes. This is a prepared sample. Nothing moves, unlike other days. Yes. I wanted to do a little bit of prepared sample microscopy because this allows us to actually use this microscope at its maximum magnification. So this is 1,000 times magnification, and I put on scale bars now so you can tell, but that is 50 microns that you can see down there at the bottom, the little scale bar that I added. And as long as I don't turn on the camera's optical zoom like I normally do, like this, now it's going to be three times the size of that, which is actually kind of hard to figure out because it's like 1/3 of 50. But if I zoomed in, now that scale bar is actually 10 microns. So it says 50 microns 5 times, but it's actually 1/5 of it. So, Dell, what's going on? Looking at some prepared slides for a little bit, and I just before I started streaming, I went onto the roof of my house. I actually just reached out the window, and I got a bunch of sticks with lichen on them. You can see the lichen reflected there, right? Is that sort of mossy green stuff? That's actually lichen. And I got 2 of them, and they're just covered with lichen. I don't know how long they've been on the roof, but the tree over our house basically just drops limbs. It's an older, big old tree, and likely to have a bunch of water bears on it. So you're gonna go on a water bear hunt on Sunday morning. You've been saving up your mosses. I almost never find them in mosses, but good luck. If you can find some in mosses, that's a win. Cindy, that's what I was wondering about the diatoms you were showing earlier on the SEM. Yeah, it's actually scanning electron microscope, SEM, but sometimes people call it ESM. I think maybe in like Europe they might use that as its, and then it's also called, it's got a different acronym in a couple of different countries, but yeah. So, were those diatoms dead too? Yes. Everything we look at in the scanning electron microscope is prepared, and it gets processed in acid and hydrogen peroxide, and then it gets put into a vacuum and coated with gold. So all of those things kill stuff. So I don't have any living samples from that. I still have some living samples from last night. I haven't returned any of that stuff to my koi pond or whatever. So if you're here to watch things wiggle, I will be putting on some water bears, and probably we will look at some of the pond sample again today. But you can't look at it at the maximum magnification on the microscope very easily because the water samples. Yeah. Were the diatoms ancient? What we were looking at on the slides earlier today was from June Lake, and I mean on the SEM, was from June Lake, and those are, I don't know if I'd use the word ancient. They've been dead for a long time. They range probably from about 30 years old samples to samples that were probably about 1,000 years old. So in diatom terms, that's not very ancient. I have some samples that are like 10 million, 12 million years old. If you want to look at those sometime, I can pull them out. But not super ancient with respect to that. But yeah, they were fossils. And these things that we're looking at were originally collected live, but they were collected live in 2017. And some of them were probably fossils at the time as well. They were collected by my friend Itzi, and they were dead by the time they got to me. She had them for months before she sent me the samples. So they were sediment samples. That's a rough preparation. I don't actually think it is. The sample prep is actually really not that bad. You just take some mud and stick it in a vial and put some hydrogen peroxide in it, and then come back 3 weeks later and it's basically digested. If it's nitric acid, usually we put just straight nitric acid in there, which is usually like 60% or something like that, and then put it on a hot plate for about an hour or two. But it's just sitting in a beaker and on a hot plate, and we come back and just rinse it. The rinsing to get rid of the acid, to reduce it down to, you know, back to neutral conditions, basically. No pun intended. And then those samples are ready to prep or mount right from there. The gold sputter coating actually only takes about a minute in the sputter coater, and so the time for, you know, processing isn't actually that bad at all, and not super invasive. If you compare it to something like pollen preparations or even phytolith preparations, it's a lot less work than both of those things. So pollen analysis requires you to use stuff to dissolve all of the silica, including the diatoms, and so there's way lower concentrations of pollen in most things than there is diatoms for lake sediments, and they're required to use hydrofluoric acid, which can kill you if you just get a few drops on you. So by comparison, that's pretty heavy duty processing. So Sam, could I explain why it's covered in gold? And hello, yes, hi. Yeah, it's because the silica is not conductive, and when the electron beam comes down and hits the sample, the electrons from the beam, a lot of them go into the sample and they knock out other electrons. But if the material is not conductive, what happens is they'll sort of work their way back up to the surface, and then they'll sit on the surface and charge, especially around the corners and edges of things, or things that stand up off of the surface a little bit where the beam is hitting it. And so if you try to take a picture of it, because there's a lot of electrons in that site, what happens is it glows, and it actually glows so much it distorts the photograph. And so when you put gold over it, what it does is it makes it so that the electrons that get to the surface basically will connect to the stub, which is grounded, and it actually takes those electrons out of the picture, basically. So it's mostly to keep the material from charging. If I were, for example, put a penny in the SEM, I would not need to coat it in gold because it's already got a metallic surface which will basically, be conductive. Some other components of things you can put in there straight into the SEM if they're made of mostly conductive material. So for example, we sometimes look at pollen in the SEM, and I probably don't need to put gold sputter. I do, but I probably don't need to sputter coat those because carbon is actually pretty conductive, and so I probably could get away with not putting it on there, but if I put it on there, it basically keeps it from charging. So that's the primary reason. Yeah. Would an element other than gold work? Yes. Any metal. And they have little targets that are made out of silver, which I have one that's out of silver. Because if I'm looking for lead, for example, the SEM actually will give us elemental information, but things that are in the same column in the periodic table will give you similar values. And so it's useful sometimes to have a metal that's not like in the row that you're trying to analyze. So if we're trying to get to analyze lead, or if we're trying to find gold in the sample, it's useful to have another metal that you would coat with it other than gold, right? Because if I'm looking for gold in a sample, a rock sample, for example, and then I put gold over the top of it, I've lost all of my ability to tell where there was gold. The problem is gold and silver are usually found together, and so probably I wouldn't want to, if I was actually looking for gold, I probably also wouldn't want to put it silver on there, but you could coat it in carbon.
Pay Maori salary.
Thank you for you gifted one to Dell. Thank you for that, Sam. It was very kind. And now Dell has all those emotes he can play with. you might put copper on it, for example, right? Or you might pick something else. Whatever the target metal that you have, nickel, something, you know, you got to make the choice on something that will help you avoid, you know, whatever you're trying to detect. In our case, I'm just looking at the surface. I'm looking at the topology or topography. I don't care what metal it is, but it's best if I pick a metal that's highly conductive, so I usually go with gold. I suppose we could use copper if I wanted to be a little bit cheaper. I probably could coat things in copper, but historically it's been like SEMs have people coat things with gold or gold and palladium mixed together. Those are the most common types of targets that are made, and because they're highly conductive. I don't usually have a lot of problem with charging samples, so I'm happy with the gold. It's just it's a little more expensive to buy the targets. So it's a confusion point for a lot of people, like why would you put gold on there? But it's actually just a little bit of gold foil. The targets are just kind of like a little tiny disc, and so not something that people would really want to steal. And if they took it, they probably wouldn't be able to get as much money as I had to pay to buy it because it's already shaped perfectly for my device. So this is another Diplonese, a different species of Diplonese. This one we're probably working on describing. My friend Itzi and I are probably going to put a name on this. I don't think it has a name yet. And that there is a Cyclostephanos malawiensis. I think there's another one back here. A couple of little fragillaria here. And that's a big one up there is Cyclostephanos damasii or CF damasii. So that's a pretty detailed explanation. For the digestion process, we usually just let it keep bubbling until all of the carbon is out of the sample when we use hydrogen peroxide. So the general idea is we want to use the hydrogen peroxide to oxidize the carbon, turning into carbon monoxide, carbon dioxide, and then basically it goes up out the hood as a gas. So any carbon that's in the sample basically disappears from our perspective. It just turns into a gas, vaporizes, and then volatilizes out of the sample and goes into the, outer space. It's not a lot of carbon, so don't get worried. I'm not contributing to global warming, but, or not in a substantial way. But so it goes from being mud that's filled with a bunch of dead things like plants and other whatever, and into a sample that's mostly silica, so we can look at it easily in the light microscope. But you can speed it up if you heat it up, like most chemical reactions. All you have to do is heat them up a little bit, and then it'll speed up quite a bit. I just prefer not to because it's a lot of extra work. I'd rather just have people, rather than waste their time micromanaging samples, we can just put 100 samples or 300 samples or 1,000 samples in the hood and let them digest naturally over time without heating them. And then actually if they sat there and did them one at a time and heated up each sample, or even 5 at a time and heated up each sample, and you were doing 1,000 samples, it would be faster just to let them naturally digest without any heating. So think about it that way. Plus, you don't have to have somebody sit there and babysit the samples this way. You just put them in and come back. Helping your wife with dinner. Okay. You always take the pipette straight. Yeah. But if you don't want to wait that long, you could always digest them in something else. Nitric acid or whatever will speed up quite a bit. So diatoms that we have right here in our field of view, this is Cockneys, which lives on plants, and that is a Nitzia. The name of the species escapes me at the moment, but I know the name of this one. And that is a Hippodonta, I think. a little naviculoid-like diatom with extra wide striae. So yeah, I think it's Hippodonta. And that is a microsphere. It's a little piece, a bead of polystyrene bead that we added to the sample, like a microplastic that we put in the sample on purpose. We put a known concentration of microspheres like this into every sample, and then I can count the microspheres when I count the diatoms, and we can use that to find relatively if there's more or less diatoms from one sample to the next. I'm not sure why the sample has microspheres put in it. I think my lab tech just did it by accident, because I don't think we would need microspheres in our sample for these. But sometimes they just get used to the process and do it. Here's another Knitsia, really faint, but you can see this structure right here. That's a valve of a Knitsia diatom. And that's a Knitsia. They're in the same genus, but different species. And that guy right there is Cimbella Knitsia, which is a pretty uncommon diatom. This is, I think, Cimbella Knitsia. I want to say Diluviana, but I can't remember if that's the actual name for this thing.
Good news, everyone!
Oh, thank you for the follow. Anuskipitella. Yeah, what is it, Del? You meant to emote. Okay. I added some emotes to the. Some emotes to the website version. I don't have it on my browser because I don't have the chat window open. But there's a Newt, a little tardigrade emote you can use now. If you go through the BTTV interface from my channel, which if you have BTTV enabled, you ought to be able to see. And it will, oh wait, I do have it, hang on, it's right here. There it is. Boop. Naphias. What Naphias? What is the difference between the Knitsias? Well, they're different species. So this one that I have it on right here, Cimbella Knitsia, is asymmetric. It's like one side is almost straight and the other side is curved. And the raphe runs on the outside edge of this valve, and then on the opposite valve it actually runs on the straight part, which is weird. For this one, this isn't the Knitsia, but it used to kind of be in the Knitsia family. It's related. And then this guy and this one, they have different shapes. So like, you know, dogs and wolves, basically, or different kinds of wolves. If you can think of anything that belongs in the same genus, and they have different outlines. So you can see this one is very long and skinny, needle-like almost, and this one is sort of football-shaped. So shape is part of it. The density of the striae. So the striae are the sort of little stripes. For Knitsia, you can't really even see them very well, unless I zoom in, which I will do here for us. Hang on. Let me put it in the middle. And I'm going to zoom in on this guy right here so you can kind of see the structure of the diatom a little bit better, because we're zoomed in, but the details are not as clear in the camera as they are in the eyepiece of the microscope. There you go. So, you see those little lines going across the diatom? They're actually composed of a bunch of little tiny holes that are called areoli in diatoms, or puncta. And so these little stripes that are right here are called stria. Stria is just Latin for stripes. And then these little structures that you can see that are down one side of it are kind of like openings. And the raphe runs along those on the outside edge on a keel, which is outside of those. And that structure is called a fibula, and that's characteristic for the Knitsioids. So everything that kind of belongs with Knitsia has a fibula like this structure with a bunch of little openings, tiny little openings along one side. And that's how you know it's a Knitsia, or a Knitsioid at least. And so you can look at the nature of these striae, the density of them, for example, whether they're straight or curved. If you can see the actual puncta, which you can barely do in the microscope here, you could use that characteristic. You could use also how frequently they occur between the fibula on the diatom, as an example. And then they have different ends and middle sections, so the shape I mentioned is sort of like a main characteristic that separates the Knitsias. So I'm going to zoom back out to normal magnification. There, we're at 1,000 times. We were zoomed in to like, whatever, 10,000 times there, something there. Super zoomed in so you could see the features. And I'm going to come back to this Knitsia that's down here, Cimbella Knitsia, just so you can see what I mean about having similar characteristics. So it doesn't have the same shape. It's not needle-shaped or spindle-shaped or football-shaped. It's shaped like a pie from McDonald's or something. And but if you look very closely at it, which we can do, and we zoom in, you can see fibula right here along one side. These are the fibula. These dark and light spots are this is the hole, and that's the silica around it. And the raphe then would have to run on the side where the fibula are. And it has many of the same characteristics. It has little tiny stripes that we can barely see, but the valve shapes are different, and the holes and the spacing and the density of the striae are all different. So it would be a different organism, obviously, different species. And that other little Knitsias, there's a bunch of Knitsias in the background that are present. That one's actually really kind of hard to see, but let me zoom in on it, just so you can see what I'm talking about and how I could tell it was a Knitsia. If you want to become a diatomist, these are important things. If you're just here for fun, it's not super information, but still useful for me to talk about it if you want to learn something. Here's the little fibula, the holes on one side of the diatom's valve, so you don't see them on the other side. And then the shape is totally different, right? So this one's shape is very elongated, sort of needle or spicular. And you can see the holes on one side, but no matter how close we got zoomed into it, we couldn't find any striae, right? So like, I'm zoomed in all the way, still can't see any of the striae. They're there, trust me. In the SEM we could see them. So if you'd have come to the stream from this afternoon, or if you were there and hanging out, we definitely would have seen the striae on a Knitsia this size there. But in the light microscope, we're limited in magnification to the point where you can't really see them. An apple pie. You think you got Chatterino working? Oh, I thought you were pointing at a rock when you were pointing at the long one. Oh, I wasn't pointing at the rock. It's just barely visible. It's this little tiny thing right here, just barely visible. And then that's the other Knitsia over there, this thing. So my pointer is, you know, it's got a limited accuracy, but it's not that bad. It's just, it's hard to see this. So Knitsia are most diatomists, they despise them because they're tiny. They're lightly silicified. Their striae are almost invisible in the light microscope, or if they are visible, they're just barely visible most of the time. And a lot of them look kind of similar, and so it takes a lot of expertise to tell the difference between most Knitsia. And they're a struggle for everybody who studies diatoms, except for people who are Knitsia experts, in which case they don't have any trouble at all usually. But they might still get some of them messed up occasionally. They're human. But they're one of the most challenging and least appreciated genera as a result of that. So compare it with something like this Diplones right here. It's big, it's oval shaped, so it's almost 50 microns in size, and you can easily see the striae and their characteristics. The raphe on Diplones runs through the middle of the valve, like this. Central, or what we call an axial raphe, runs down the middle of the axis of the diatom. It's slightly bent. If you were to put a ruler across there, you'd see that it's not perfectly straight, but it's close to it. So we would usually refer to that as an axial raphe. And then there's another diplanese over here. There's a lot of them in these samples. Most of them don't have names. Or they have wrong names, maybe. And then this guy that you can see is, this is a Cyclostephanos damasii. I'm going to try to get the focus a little bit better than it is. We don't need to be 10 times in, but a little bit better is useful. Now the scale bar is wrong, so just ignore it. But you can see a lot of the detail on it, and those little holes that you can see that are in kind of radiating rows coming out of the middle here. Those are striae, or in these things we usually refer to them as fascicles. So we were looking at some Stephanodiscus, and Cyclostephanos is closely related to Stephanodiscus earlier today on the SEM. And I sort of listed off all the characteristics of it. Spicula. And one of the things that's cool about this particular guy, so I'm not sure if this one has a name yet, people just call it Cyclostephanos CF, which means compare with damasii, but I don't actually think that it's damasii, and I don't think anybody else thinks it's damasii, and I think there might be some cryptic species in here as well. So one of the things that's kind of cool though is its surface, the very top of this thing, the valve face. So if you think of it like a kind of cap shaped, right? So it would be this part, the flat part of any sort of cap of a thing. So if we think of this as being the diatom, that's the valve face. For this organism, the valve face, yeah, it looks a little bit like a sunflower. It's a good observation, pragmatic. In this case, the valve face, like a sunflower's face, has what's called a concentric undulation. So like an onion has concentric circles, but in diatoms, when the face is deformed, they call that an undulation. And when it's concentric, it's shaped like a hat, like a sombrero or something. So, and you can see that very easily if you use optical dissection. So here you can see the valve, everything that's in focus is at the same elevation. So when I change the focal height, you'll see the center go out of focus, the edges come into focus, and then the edges go out of focus. And they happen in rings. Like right now, the outer ring is completely in focus, and then its neighbor, its neighbor, its neighbor, and now the middle has come into focus. So as a diatomist, you can use that, and it tells you that the outside to the inside and back to the middle and back to the edge has a bump on it, right? So in my eye, when I glance in there, I immediately can tell that it has a three-dimensional shape because everything's not in focus at the same time. And that pattern I recognize as concentric undulation immediately as well from seeing it so frequently. It's not the only type of undulation you can get in centric diatoms. You can also get something called tangential undulation, where it looks like a wave sort of passes through the valve face. And I don't know if we'll find anything that has that pattern in this sample. I don't remember if there's anything with those tangential undulations on them. But we can go looking for some and see what we find. So we're still looking around at 1000 times magnification, and now the scale bar is correct at the bottom. Is this fossil? Yeah, well, it's a prepared sample, Jolkson. It's prepped and mounted in nafrax, which is a special type of resin that we use for diatom preparations when we want to look at the skeleton. So these samples have been processed using hydrogen peroxide and nitric acid to get rid of all the organic matter, and basically we're just looking at the skeletons. And there's also like silt grains in here, so that's silt. Those are silt, or maybe some of them are bordering on sand size. No, those are silt, that's 50 microns. there's like sponge spicules and phytoliths. I saw some phytoliths earlier. I forgot to point them out. And there's probably some chrysophytes in here. Anything that's siliceous will live through it, will persist through it anyway. The skeleton will. So here's another example of a Knitsia. We were looking at some Knitsia earlier, up close, and I was saying how much everybody hates them. So there's no reason for us not to take a look at one of them, though. From here, you can barely tell that they have all the features of a Knitsia because we're zoomed out a little bit. But I'm going to zoom into this area, and you can see all of the same features again, even though this is a different species. The fibula on one side, all the fibulae are right there. You can see them if I focus a little bit. You can see the little bumps right there. That's the fibula. And then these structures here are called the striae, stripes that you can see. And they're perfectly clear in my microscope, but my microscope is exceptional. And probably if you were looking on this on somebody else's microscope, you might not actually even be able to resolve those striae because they're so fine. It's something like probably 22 to 24 striae in 10 microns. We could measure it probably if we wanted to, but it's super finely striated, and that's one of the reasons why people hate Knitsia. So the shape is a little bit different. The striae you can actually see on this one. So it is spicular like the other ones that we saw, but in this case it's coarse enough or dense, low density striae enough that we can actually see the striae. So Trappy says, one of my frustrations with light-based microscope is that everything is 2D. I wish there was a way to get a clear 3D picture of things while they were alive, like creating a box that shows them in 3D. There is. A confocal microscope will do what you're hoping for, somewhat. It will give you a 3D image of something while it's still living. I don't have a confocal microscope, but it basically creates 3D images or scans 3D image kind of like structures. But since I have an SEM, I don't really need it. And because I usually look at things that are dead in the SEM and also in ancient sediments, that's my primary objective. I don't really need a confocal. If I didn't have an SEM, a confocal would probably be next up. Yeah, tomography microscope hybrid. Yeah, that's basically what the... Yeah, I don't think Pacific's microscope would show them. Hi Pacific Plankton, how you doing? We should, well, I have the oil immersion on, so, but you may or may not be able to see these ones. Forgot to do these things. I got these cool people-based shout-outs. You're sleepy. Is the vaccine shot number 2 doing a number on you, making you tired? Or we just had a busy day. I guess either way could kind of knock you out. You might not be able to tell which one it is. Yeah, so for prepared samples like this, it's kind of nice. You can zoom in a lot closer. We have oil, I'm in oil immersion. And so you can see a lot of the detail, but of course nothing's moving because it's all been processed. So that's a pretty cool looking sponge spicule right there. It's got kind of gnarly spines on it. And I promised I would say something about phytoliths. There's a phytolith right there. This is a phytolith. Actually, it's several phytoliths all bundled together in a cluster. But you can see they were the outlines of plant cells. And the silica gets deposited. It's polymerized and deposited basically between the cells or outside the cells or sometimes inside the cells for different types of phytoliths. And in this case, it's the outside of the cells, the plant cell wall that's been silicified. The cell would have been inside of these pieces. And this actually is a piece of charcoal. And you can see a little bit of the charcoal plant material still attached to the phytolith, which is a pretty common situation that I find where the phytolith, if it's coming from like a grass or something that got burned, then it gets blown by the wind and lands in the lake, and then we get a fragment of it with the actual charcoal still trapped in it. So you were puzzling until almost 1 a.m. Yeah. Well, I mean, I was puzzling till like whatever it was, 3 a.m. So, you know, I know where you are about that. Phytoliths are basically the bones of plants. Yeah. Well, not quite, but that's sort of what they... Plant rock, right, is what it means. So... Well, anyway, I was just kind of poking around in this old slide, looking at some of the Diplonies, and I got these scale bars working on my... finally put a scale bar on so I can easily put up the size of things that we're looking at, as long as I don't zoom in. And then I made some for when I do zoom in even. But I didn't make any for zooming in on this level yet, which I suppose I should have. It's a nice pretty Diplonies that's completely flat. So you can see all the detail on it pretty closely. I'm just going to zoom in on it because what a pretty diatom, right? That is Diplonies, and this one probably doesn't have a name. Itzy and I are probably going to put a name on this sometime this year or next year, hopefully this year. I think she's naming this one after her current boyfriend, but I'm not positive that this is that one. This is the raphy structure right here, and for Diplonies they always have this thing going around the outside edge. It's like a break in the striae. It's actually a little canal that is on the inside of the diatom, but you can see it as sort of a break in the striae on the outside of the valve, because we can see through the skeleton. And then the raphies kind of look like thermometer bulbs to me. They're always kind of like fat because they sit in a little canal. The actual raphy, though, is kind of skinny. It's this thing. So this is not the raphy out here, but this part is right here. The dark part is the raphy, and in the SEM they're just really little tiny hairline like structures that you can see, but they've got a canal that they sit in basically that surrounds them, and it makes them look a lot bigger, wider, like I said, like thermometer bulbs or something kind of. They're very big. And then these look very three-dimensional, these structures right here. They might actually stand up above the surface a little bit. Look at this. It's District 10. And I got command for 10. 10 for 10. Such a perky orange arrow. I made this in PowerPoint all by myself. I was very proud of myself for a minute there. I was like, how am I going to get this to look right? And then I thought, nah, I'll just make one. It's an easy way. I like it. Park it down here at the bottom. Scale bar is pretty cool. Yeah, earlier I put a stage micrometer on, so I borrowed one from somebody. I was supposed to get one with the new microscope, and the microscope guy forgot, but they're only like 10 bucks. He just didn't include it in there. And actually I was supposed to get a reticle for the eyepiece, and he didn't include that either. So my microscope guy, I know he's not watching, but the Leica guy, two things he let me down on right there: the scale bar in the eyepiece and the scale bar on the table, or on the actual like microscope that I could take and put on and off. Come on, Bon. It's like a football, and you know, some diatoms are football shaped. This one is kind of football shaped. I like Diplonies, but they're really a pain to identify because they're all really similar. They just have really subtle differences in their outline. And then also, if you're focused here versus being focused up here, they look totally different. So like the areoli look like squares when I'm down here, like blocky squares. And if I move up to here, they actually look like, I don't know, triangular almost shapes. And so depending on where the person who was taking the picture focused, like this is the appropriate focus right here. But if they had it on the other one, they'll look blocky, and then I won't be able to identify very easily. It's difficult.
Good news, everyone!
Yeah, I made one for mush and I made one for 10. I think I did one night and one the next night, and I forgot to take out the mush one, so we have them. You have two.
Good news, everyone.
You have double the number of shout out terminology, in case I forget which one. Thank you for the follow, 325. This diatom is Starcirella africana. It's a well-known diatom from Eastern Africa, and we've seen it in the SEM before. I've got pictures of it as well there, but really pretty. It has a big empty middle spot in here, which is unusual for Starcirella, but these big thick striae on the margins. And if we were really careful, we could see that it has an apical pore field down here, and up here you can barely see a difference in the tone across these two. Right there is sort of brighter areas because it has apical pore fields. And then in the right light, we might actually, not on this one, but we could potentially, if we had a bigger one, we'd be able to see that there's little linealations across the striae on this. So, is there a diatom book I can recommend? Mr. Boo, I don't know that there, I mean, for like a non-science person, or like you want to become a diatomist, because there's not really like diatom books for non-diatom people. If you want to become a diatomist, or if you want to become a paleoecologist, I have lots of books I could recommend for diatoms or otherwise. If you just want to have like a fun light read, I don't have anything like that, unfortunately. I don't think anybody's written anything like that, to be honest. At least I've never seen anything like it. There is some videos. Oh, I probably should point this out while we're here. Anybody know what this is? Anybody have any ideas what that thing is? Right there. Just let you sit on it. Maybe somebody knows. No diatom kid books. Actually, there are diatom kid books. If you were interested in coloring, for example, I could recommend a book. Or if you just wanted to learn about diatoms like a kid might, or if you have a kid and you want to teach your kid about them, I could recommend books. If you want to read about them like it's a story, or you just want to learn about, you know, the history of diatomists, I don't think there's a book for that. You know, there's probably an opening there if somebody wants to write the next American novel about early German diatom taxonomists, or some famous Russian diatomists, or even the American ones. But we don't really have books like that. If you, like I said, if you want to become a paleolimnologist or a paleoecologist, I could recommend a lot of good books about diatoms. I'm in a book chapter in one of them. I've actually contributed to one of them. But light summer reading? Yeah, diatoms.org is a good place to go. So that link that Pac put up there is a good choice if you just want to like learn about diatoms. Spunky girl diatomist. Well, there are some. Ruth Patrick is pretty spunky. She's super famous and a diatomist, and one of the most famous women scientists with respect to contributions to science. Definitely worth learning about. And she might have some interesting interesting biography, but I don't think anybody's written that book yet either. So, anybody have any idea what this thing is that we're looking at while we're here? No ideas. 25 viewers, and I stumped you all. The ones that are awake, anyway. This is volcanic ash, actually. That's tephra. It's got these really sharp edges. It's glass for sure, and it's sort of vesicular. So it's not sand. Well, Technically, it would be silt. Tephra? I can spell tephra. Tephra. That just means stuff that got spit out of a volcano that's small. You know, like when a volcano erupts, the stuff that goes up into the upper atmosphere is tephra. Oh, it's a new word for you? Okay. Well, usually we just call it ashes. Because I'm lazy, I call it volcanic ash. But functionally, if, you know, Volcano Doc was here, she would refer to it as tephra, probably. So, she might call it ash too, I don't know. She might be as lazy as I am. I don't want to let her off the hook too easily. Here's some more. That's also volcanic ash right there. You see the, it's got like a diatom trapped in it. It's a little channel with a diatom stuck in it. These long stretchy things right here, they used to be air bubbles inside of the, when it was lava, when it was hot, or magma even. I guess it was starting to cool, so lava. When it was lava, and their air pockets basically get stretched out into these long sort of vesicular shapes, and then the edges are conchoidally fractured, so those are usually the ways that you can tell that you're looking at a piece of volcanic glass. Lazy word user. That's me. I know all the words, but I only use the ones I like. Actually, I like the word tephra. It's very specific. That's a sponge spicule right there. And another one. Those are megasclerae. You know how I know they're megasclerae? Because they're bigger than 100 microns. And now that I have my scale bar on there, we can actually tell that they're bigger than 100 microns. Because that's 50 microns, and that's more than twice the size of that. And so is this one, right? Those are what we call megasclerae. And if they're smaller than that, they're called microsclerae. So it's some sort of a sclera either way. Sclera just means like part of a sponge. Sponge part. Alright, it's what time is it? Is it 10:30? My camera is on the other side of my 10:38. On the other side of my my clock's behind it. It's probably a good thing, because I don't pay attention to what time it is. But that's one of my favorite diatoms. It's a little mangled though. So I also wanted to look at maybe do a little bit of a water bear hunt with you. It's raining here. It's been raining all day, and there's another phytolith for you. Right there in the middle, that dog bone shaped thing. It's a bilobate. 1 hour. We spent 1 hour looking at this stuff and talking about diatoms. I've taught all kinds of words, like tephra, and concentric undulation, and fibula, striae, areolae, raphe. I'm gonna make a long list. I should probably just keep a list of words that I've taught people, and then type them in one by one to my chat commands, so I can have a monster-sized list of chat commands. You know, even bigger than I have now. I'm gonna make my bot do all the work. It's a pretty diatom. That is currently in the genus Gomphanema. It probably doesn't belong there, though. My friend Itzy and I are secretly exploring this thing. It's a weird diatom. It doesn't have the characteristic features of Gomphanema the way it should. And nobody looks at African diatoms besides me and a couple of other people, so it hasn't been carefully re-examined in the context of modern Gomphonema. But we're on it. We're looking at it at least, and I think she's got some DNA of it, so we can compare it to actual Gomphonema. But characteristics that would put it into Gomphonema that make it similar or almost the same as Gomphonema: it has a head pole and a foot pole. One side is shorter distance to the middle than the other. So this one's slightly longer than that one, and hopefully you can see that also the shape is a little bit different. It's kind of like a submarine or a teardrop. It has one side is a little bit wider, fatter across the middle, and then this one is sort of skinnier across the middle up through here. And that asymmetry, where you can fold it along the axis, but if you tried to fold it across the axis, like here, if you tried to fold it this way, the ends would not touch. Makes it gomphonemoid or gomphosymbelloid. Gomphonemoid symmetry, where you can fold it across this thing, but you can't, you can fold it along this thing, but you can't fold it across it. Puts it in with the gomphonemas immediately, and then this little structure right, so in the middle, running down the middle, is the raphe, and then things on the side that are radiating out are the striae. Those are all the same characteristics that we've been looking at. And then if I zoom in nice and close so you can see it the way it looks in my microscope, it's actually a little closer than what it looks like in my microscope, but that is a stigma, and the stigma is sort of teardrop shaped, and a teardrop shaped stigma takes it out of gompphonema. It shouldn't be shaped like that, but it is, and so it's either a very extreme version of a gompphonema or it's not gompphonema at all. So on the inside, that thing is a slit. On the outside, it's a hole, and so it looks like a teardrop when you see through it. But the raphes branch much in a similar way. That's a feature actually of Afrosymbella, and the raphes kind of look a little bit like Afrosymbella raphes on the inside, but it doesn't actually belong with Afrosymbella either, because Afrosymbella should have asymmetry in two directions. So not a gompphonema, not an Afrosymbella, not a symbella, none of the other gomphonemoids. Kind of belongs in its own group. The only diatom work I have seen regularly is by Sophia Passy, yeah. But that is US and Europeans usually, I think, yeah. Has a 3D structure from CT scanning being done with... Oh, has 3D structure from CT scanning been done with any diatoms for their structure? They're a little too small for CT scanning. People have used, they've dyed them and used confocal microscopes to look at their 3D structure. You know, to make a 3D model, I think is what you're talking about, but an SEM would be better than that as a way of looking at the structure, because you can see a lot more detail with an SEM than you can with a CT scanner, even a micro CT scanner, but it will give you the three-dimensionality. But you could use an atomic force microscope if you wanted to look at the three-dimensionality of it pretty easily. It will create a 3D model, but atomic force microscopes are super expensive, and I only know one diatomist who has one, and he doesn't do diatoms much anymore. But we have done, rather than tomography, we have done photogrammetry using the SEM, where I took 70 different photos of one diatom and I rotated it and tilted it, and from that we created a 3D model. It's only half of, it's like the outside part of a diatom, because you can't see the inside and the outside at the same time. But we could do the same thing on the inside of a diatom, take a bunch of pictures and build a 3D model from that. And then you could marry them together. It just might not be perfect unless you had the exact same size diatom, or maybe you had one that popped open and you got the inside and the outside sort of sitting next to each other. So if you micromanipulated it to do that, you might be able to marry two of them together perfectly. I haven't tried to do that, but I mean, we have the technology to do that pretty easily. So, to answer your question, I don't think so. I was just trying to see if this thing has a horn, because a lot of these things that are in this group actually have horns, like a unicorn on the head pole. This one does not appear to have a horn, but I'm not looking at it sideways. I'm looking at it from top down, and sometimes you can't see the horns. So sometimes it takes a special view to see the horns. That piece right there is part of the raphe. That's a branching raphe. It's, I think, and if it had a horn, it would be right here, sticking out. So it could be this structure. And I've seen some like this. The horn is very subtle. Like, you can only see it when it's on its side, basically. And it's just barely visible. And when it was identified and described, this species originally, they didn't point out the fact that it had a horn, because I don't think they saw it. Even in the SEM, you have to be looking for it to see it, but I think it's actually this little bump right here. It looks like a stripe, but I think that one of these in here is actually a horn. A little horn structure in there. Because I think everyone that we've found like this has a little horn, like a unicorn or a goat. Yeah. I don't have any horns to put on, or to put on it, actually. But if it was like a little devil diatom, you know. We have found diatoms with horns before. The stuff from Idaho that we have is the same kind of diatom, kind of, but it's actually a Gumphanese. I think it's a Gumphanese. It belongs to Gumphanese, but there aren't any Gumphanese in Africa. It's a genus that does not exist in Africa, or at least should not exist in Africa. It evolved outside of Africa, and so there aren't any. Or at least that's what my friend Pat tells me. And then when I tell him things that I think are Gumphanese in Africa, he looks at them in the SEM and he goes, oh, those aren't Gumphanese. They just kind of look like it. So, much to his relief, because he's convinced they aren't there. And so far I agree with him. I haven't seen any that I know for sure are Gumphanese. But they do have Afrosymbella, which seems to have taken the place of Gumphanese in that system. Alright. So I wanted to do a little bit of water bear searching, and I can't do it unless we shape down these sticks. So let's see if I can make that something we can actually see me doing. Apologies for shaking the camera all around. It's sitting on a weird little tripod, but it actually lets me do things like point it downward. So you can kind of see what I'm doing here. This is a stick from the roof of my house. I reached out the window, and it's raining out there right now, lightly. But it's got lichen all over the top surface here, and all I'm doing is lightly scraping the lichen into the bowl, hopefully not getting all over the floor or my pants. And it's actually kind of soft because it's been raining, which is why I'm being extra careful. Usually when it's hard and I do this, I'm a little less careful. But you can see hopefully you can see the lichen coming off into this little delightful bowl that I stole from my daughter. It's purple. She normally just eats snacks out of it, so now she's big enough, she just eats them out of the bag for the most part. But she's got more, so it's not a big deal. We can sacrifice one of them for science, I think. Alright, so I scraped it all, or almost all of it off. There's still a little bit here that I didn't scrape off, and also on the side here I didn't scrape some of that off. I'm just going to leave it in case there's something exciting in here. And then I got another stick from the roof as well. This one's got some sort of gross fungus growing on it, but it's mostly this lichen stuff right here. Hopefully I'm not ripping any tiny little water bears or rotifers apart when I scrape this, because the knife is actually a lot bigger than a rotifer. So it's probably not something that's causing damage to them. But if we see any when we are looking around in the sample and they look like they've been chopped in half, wasn't me. I'm just gonna say right now. Must have been something else. I didn't do it. Dead water bears got killed by something else. So this is the collection process. You're watching all of it except for the part where I reached out the window and grabbed these sticks from the roof of my house. I'd have to go upstairs to show you that part. I don't have any way to stream up there at the moment. So this is nasty sort of mold or fungus or something growing on there. We need District 10 to tell me what that is. I definitely didn't just wipe a bunch of it onto the floor. But this is what came off of it, right? You can see that. It's got the same green color as the lichen that was on the stick. Some of it's a little white colored as well. That's it. We did it. We got the lichen off of the stick. I know, it's a tiny little image in the corner, but hang on a second. Is it this one? Oh, I have it locked. That's why. I was gonna say, I could make it bigger. I could show it bigger. There you go. There's the lichen. Right? But you just saw me scrape it off of this stick. It's not all that exciting to watch, right?
Good news, everyone!
You missed it. Oh. I don't know what this stuff is. You know what that stuff is? Sorry. It's like black and sort of floppy. On the stick. I think it's maybe a mushroom or a fungus of some type. It's just growing on the stick. There's some more of it right there. Right here. Not sure what that is. The green is lichen, I know, but the brown stuff looks like some sort of a fungus. It's very wet. Alright, so in order to get the water bears to come out, I've got to put some water in here. Put it under the scope. I could do that. That's a good idea. Why not? Just a weird, gross little thing I found. Kind of brown colored. Let's see what it looks like under the microscope. As long as we're here and we got a microscope, why not look at it under a microscope? And we got the mushroom guy here, right? Maybe they'll be able to tell us if it's a mushroom or something else.
Good news, everyone!
Not in that focus. Oh, that looks very mushroom-like. Hang on. That right there, that looks kind of mushroomy, doesn't it? Let me fix
Good
something.
news, everyone!
I'm gonna fix something else while we're here. That's not the right thing. We're on 5x. What kind of tree? It's a bur oak, and a really old one. So the wood is a bur oak wood, and I don't know if that helps, right? It's definitely organic. I think it's a mushroom or some sort of fungus, don't you? What else could it be? That skill bar's wrong now, just ignore it. I don't think it's a lichen. It doesn't look like a lichen, and it's like floppy. So, I don't believe it's a lichen. It was growing on lichen, right? I'm gonna leave that there, and then I'm gonna make District 10 tell us what do you think it is. I know the battery's going again, it's okay. Don't worry, T-Perm. I got another one over there that's totally charged up. I'm gonna go get some water and put it in with the water bear. This is a critical ingredient of the water bear is the water part. So you have to add water or you won't get the bear. You know, you'll get it, it'll just look like a little blob. That's enough of me being giant size. I'll go back to being tiny and in the corner. This is the sample we've been looking at for like an hour for some reason, while I talked. Conveniently labeled Etsy 73. And it's one of hundreds of samples from Etsy. She's supposed to be sending me some more. I'm also going to get some samples from Pacific Plankton in a day or two. And I'll have something else to look at on the microscope when that happens. Polypore. Black knot fungus. See? I told you it was a fungus. District 10 mushroom says it's a fungus. So, right there. Apiospirina morbosa. My random Latin words are coming through great. I don't want this one. Somewhere I should have a little pipette that's clean. Guess we can just use this one. If it gets some other random things in there, we get some other random things in there. So I'm about to make a sample from the lichen that we just looked at by I'm sucking it up in a pipette, right? So we looked at the lichen, I scraped it into the bowl, I added some water. Now I got a pipette full of lichen. And I'm just gonna put it down on the glass slide here. For some reason, whenever I do this, the first sample I look at rarely has water bears in it, and the second one usually does. And I don't know if that's just because I didn't give them enough time to rehydrate before I started, or if they kind of work their way out of the mass of other stuff that's in there. But I didn't put a cover slip on this. And I'm going to take the mushroom off, sorry, the fungus off. What's the difference between a mushroom and a fungus? District 10. What's the technical difference? How do I know if I'm looking at a mushroom or a fungus? Like, Obviously, mushrooms are types of fungus, but if I have something else that's a mushroom and something else that's a fungus, but not a mushroom, what are the characteristics that make it? Mushroom has the fruiting body. Okay. Oh, Pacific Plankton knows. I'm pretty ignorant when it comes to mushrooms, so you need to stream more often. We need to see some of that stuff you got, and then maybe I can learn. Alright, this is just straight out of the lichen. Well, it is the lichen. I didn't do anything, I promise. I just added water. And then spilled some of it on the microscope stage when I was putting it on here, so always a good sign.
Alright, let's bring that beat back.
That is a big piece of lichen right there. It's distorting our field of view because the water it's above the water line. Okay, I need to make some minor adjustments, like this one and that one, to make my microscope look pretty. And then we'll start our search. Oh, I found a nematode already. Starting off good. Goal is to get back online in May. What month are we in? April? It's gotta be close, right? I found us a nematode. This one looks a little beat up. It maybe got caught up in my knife.
Good news, everyone.
Metalunawan. Hello. Welcome in. We're looking at a nematode that I found in some lichen that you just saw me sample if you were here. And I added some water, and this thing is very excited about the water. It's happy to be alive. For now. There's also a little bit of moss in here. That's not just lichen, because that green thing right there is actually moss. I didn't sample moss, I sampled the lichen. There's some more nematodes. They're still waking up, so forgive them if they're not wiggling around like they usually do. You left and you came back to see nematodes, yeah. This is why you followed, because you wanted to see nematodes? I mean, we look at nematodes pretty much all the time in here, so you're in the right place. I screwed up the scale bars wrong again, so hang on, we're at this size. Your network is wonky. Well, the good news is you're not streaming. You're not streaming tomorrow either, are you? I get the night off. I might go to bed at a reasonable hour because you're doing your microscope meeting thing. Is that tomorrow? Is that the right date? I don't have a Pacific Plankton event button in here, but I do have this. Watch this. Boom. Everything you want right here. I just add it as a bot command now. People on the channel, whoever's here, you should click on that link. It will take you to Pacific Plankton's Pulse of the Plankton YouTube, where she posts videos of all the cool things she found in the plankton the last week or two, and then you could follow along with it. You could subscribe. It'll be great. Entertain yourselves when we're not on, when there's not someone else here. Oh, there's a rotifer. This must have came out of the pipette, is my guess. 'Cause that's a planktonic rotifer. So it's either raining a lot harder than I thought it was, or that thing came in with the pipette. Little contamination. Just ignore the fact that it's the wrong kind of sample for that. Nematodes are back awake. This one's ready. This one's ready to start wiggling like a crazy fiend. Oh, you subbed too, yeah. Thank you. Doesn't my channel take you there? I thought the link I gave takes you there, doesn't it? I think it just goes to the featured video. I guess I could put that one on there if you'd prefer. Look at the wiggly worm. It's going nuts. We could zoom in a little if you want. I made a thing for this one though. It's this one. There we go. It's a little bit too close, I think. We can't see the worm very well. We just see the, like, it's flexing. So maybe we'll go back. Straight off of a tree branch that fell onto my roof. Yeah. He might be stuck. They're surprisingly strong. I found that the nematodes that, you know, in the lichen and samples that we've looked at, they push stuff around. They're pretty good at it. There's something that used to be alive right there. Maybe it's still alive. It looks like a squishy rotifer. They usually have like a pinkish color in my microscope, so I can usually pick out water bears and rotifers a little bit more easily than, because they're kind of pinky colored. Step. Oh, this thing? Right here? That's a mite. That's the mite skeleton right there. It's dead. It either molted, or it actually died, or maybe it's rehydrating. But that is a mite. There's lots of mites all over the place. You don't really understand everything I say. You know what? Elkie, sometimes I don't understand everything I say. It's not a big deal. Just look at the cool pictures if you don't want to learn stuff. It's fine. That's what I'm here for. Or you could just try to learn stuff and ask questions, and I'll try to answer them. And then maybe eventually you'll understand what I'm saying. Either way's fine with me. As long as you're entertained and you're here. I swear there's some people who just come because they want to hear me talk. They don't care what I'm saying. They're just like, keep talking. There's a little nematode. There's another mite. Right there. Let's see. There you go. You can see its legs. I'm gonna put the arrow where its legs are. Oh, it's wiggling its leg. I think this one's alive and it's rehydrating. Or it's also a fan blowing around. I think this one is rehydrating. Hey, Shako2T. Hi, how's it going? Are these things visible to the naked eye, or are they just too small? Well, where we are zoomed in right now, sorry, that's the correct scale. So down here, that's 1/10 of a millimeter. And this thing, like if we looked at the whole length of its body, is probably about 6/10 of a millimeter, about half a millimeter, a little bit bigger. So you can see a millimeter. You know, anybody with a ruler can see a millimeter. It's the smallest tick on a ruler. that has metric, and so something that's a 0.5 millimeter you would see as a speck, but you wouldn't be able to tell it's a bug, right? You wouldn't be able to tell it's a... Randomly you came here. Earlier I took some of these sticks off of my roof, Shako, and from a bur oak tree, and they're covered with lichen, and then I scraped the lichen into this bowl, and I took the sample from the bowl, put it on the microscope, and we're looking at that. So currently I found a mite, that's what this thing is, and we found some nematodes, and I saw a planktonic rotifer that doesn't belong in the sample. That's pretty much what we've seen so far. We're just working our way through this sample, and then I'm gonna put another one on because the second one is usually the best one. First one usually goes poorly, and it seems like that's going to be the case here. And eventually, hopefully, we'll find some rotifers and some water bears. But sometimes you have to look through a couple of samples to find either of those things. They're not super dense in the environment. Nematodes we found. They're pretty easy to catch. And then, yeah, we did see some sort of a planktonic rotifer, but shouldn't have been there, but is. Because I used the same pipette that I used to get a sample from a pond. I might have to turn the fan off, because I think the fan is moving the particles around, making me think that they're actually being moved by organisms. And it's distracting, because that's how I usually tell where there's something behind other things. That's a nematode. I think one's dead or it's still rehydrating. There's a nematode that's not dead or rehydrating. It's twitching on Twitch. Appropriate. Oh. Uh-oh. Rotifer. That is a Deloid rotifer. It's hiding under all this junk. You can see they kind of have a pinky color. There it is. It's still hiding behind all the junk there. Now it's got its little antenna sticking out. And there's its back end. And that's its foot right there that you saw stick on the glass for a second. That's its foot that looks like little horns with its toes. Nematodes are those kind of worms. Yes, they're a type of worm. But this is a rotifer, not a nematode. And it's not a water bear. Not yet anyway. We might find some. And there's also a little bit of Spirogyra from my pipette in here as well. Doesn't belong. Some more nematode worms. That's a big one. And off to the left here is a little one. Let's see what else we can find. Nematodes. Another nematode. We're almost all the way through this sample. Another nematode. That one's not moving. Another nematode. This one is moving. Can we start a poll? But the battery will croak the second you spot it. Water bear. Yeah, Pack, learn how to pull. You just type pull, like \pull. Super easy. And then you put whatever you want the voting things to be in there. But I do have another battery, so it'll be okay. It will be fine, Sam. Don't worry. If that's the case, I'm gonna move on from the dancing nematode who's vibing to the music and see if I can find a water bear. That way I don't screw up the poll. That's a rotifer. Sorry, I thought we had something, but there was a little rotifer in there. There he goes. He's like peeking out from behind the... There he's now. He's peeking out on this side. She, it's bedelloid. They're unisexual. Always a she. Not even mostly she, just always a she. That's a nematode.
Good news, everyone.
Thanks for the follow, Shaco. Hopefully you're enjoying microscope content. There's another nematode. A couple of them sitting on the edge of an air bubble. Oops. What's that? It's underneath the bubble. I can't really see what it is, but I think it's a rotifer. I guess we still have a ways to go. Uh-oh. Uh-oh. Did the poll get up yet? Did we get the poll? Because that's a water bear. So, the battery didn't die yet, but that is a water bear. Yeah, water bear. So, if you were gonna vote yes, you're wrong. The pack's still trying to figure it out. This one's still rehydrating. It's very slow about coming back to life here. We just added the water a little bit ago. Content doesn't meet guidelines. What did you put in this poll? There's its head. It just moved its head towards us a little bit right there. And then those are its little clawed feet you can see. That's a foot, 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 and that's a foot. Those are the front 6 feet. And then it has 2 feet back here that are like, the back feet are like hinged together, and they're sort of backwards facing because they use them for grabbing stuff. And that's its little newt mouth right there. So we'll put one of these in here. Woo woo! You can see it's moving its little claws. It's like very sleepy, right? Its little claws are moving right there. That's not the wind. That's actually the water bear moving its feet. So I do have a fan turning up there, but it's not the fan blowing it around. That is the water bear's animating its head and its legs. So this one's alive. The other night when we were watching, I did a water bear hunt. I think it was last week. We went looking for water bears, and we saw one molt. We saw it like wiggling out of its skin. So if you're really interested, you could go back a couple of weeks and see that. Trappy, it'll be fine. I have more batteries. What is the thing to the right of the water bear? What are those things called? Trichomes or something? You always put a name on them, don't you, Pack? They're like hair plants, little hairy plants. It's got its back claws kind of touching up against it. Trichomes, yeah. Some sort of a trichome. You can actually see the little, this one has little things around its mouth. Little hair-like mustachy things going around its mouth right there. And then these are usually little eye stalks that are poking out on the sides. I think that's its eye. We're looking at this thing from the bottom right now. So, this has become your favorite stream on Twitch? Yeah. What's up? Have you been to Pacific Plankton stream? Or Del Maximum stream? Somebody's in here. The nematodes decided it wants to photobomb our worm. Is working its way into the picture with the water bear here. That's a big water bear, by the way. That's a mama, a big mama. It's butted into the water bear now, and it's bumping it around. When will the battery stop? Hey, the pole works. It's working. Random thought. DX executor. I usually machine stuff to work down to 0.05 and 1 millimeter, and I find it weird that these creatures are kind of in that range. You would have thought they'd just be much smaller. Some of them are. Earlier we were looking at diatoms, and the diatoms we were looking at were in the 50 micron range, so I guess that's in the range you were talking about, but some of them are much smaller than that even. Water bears, however, sorry, this is actually, I put the wrong thing on because it's hard to keep up with it. We're actually at this size range, right? This is 10x with no modification, yeah. So, yeah. iTunes Visualizer is based off of a microbial environment. I think it is so cool that we can see the real thing here as you describe it. Hey, thank you for clipping that, Shako. I'm glad people they're excited about the water bear and the nematode and our crazy colors because of the water droplets are starting to dry out. That water bear is super slow about waking up, but it's definitely still alive. Sometimes they go into this sort of sleepy mode where they just don't move very much for a while. If either they've eaten recently or they, I don't know, this one looks like it's kind of shedding off the exoskeleton, so maybe it's planning to molt. Regarde ce clip. There you go. When will the battery stop? In 10 minutes. Okay. You can feel free to gamble all you like. Turkey, a tamer. Hello. We're looking at a water bear. This one's alive. It's moving very slowly. That's its head. That's its legs. And that is a nematode that's like harassing it right now. So she's kind of trying to sleep, but you can see the little claws on her feet wiggle every once in a while, and her head move around. And the nematode back here is kind of being pushy. So, yeah, you can see her head's moving right now. And also, I thought I saw a little heartbeat or something in here. Some sort of organ was moving around. That worm is so... It's just cracking me up. It's just doing whatever it likes back there. It's like, wake up, water bear. Charging its own spirit bomb. Yeah. Alright. I know where this one is, so we can come back in a little bit and see if it's awake, if my battery lasts. And if it doesn't, I'll put another battery in. It'll be okay. Let's see if we can find something else here. We've been going this direction. before the slide totally dries up, because it's working its way towards that. There's a rotifer. This one's on the move. See all the diffraction coming from the what's going on there? Maybe there's two rotifers over there now. Coming from the water droplets. You learned about my channel versus via paleontologizing. Yeah, paleontologizing is a great streamer. If you don't know who paleontologizing is, I got a bot command for that. Only one though. For district mushrooms I have 2 commands, and for pack I have like several commands apparently. So, welcome in. This is your first or second time here or whatever. We look at stuff in the microscope. Sometimes it's living, sometimes it's dead, sometimes we go on a water bear hunt, which is what we're doing right now. And we found one, but it was sleeping. And the worm was trying to wake it up. Unsuccessfully, apparently. And I have a lot more sample to go through, but so I thought maybe I should try to look around a little bit more. And we'll just put another sample, another piece on. A little bit more on this cover slip. One of the nice parts about not putting a cover slip on, actually, is that... oh! There's a mite right there, and this one is active and alive. Sorry about the psychedelic oranges and blacks. That's not... that's just because it's... the water's drying up. But that there is a mite. It's dealing with the fact that the water is drying up. So check out 8 legs, not an insect, right? $11:30. I don't know when the timer started. How big would that be? Oh, sorry. Hang on. I have a scale bar. It's just I put the wrong one on. That's the scale bar right there. So this thing is about 1/3 of a millimeter, or 300 microns if you'd like. It's in that range. Pretty small, but bigger than diatoms. Most diatoms anyway. Oh, okay, I see. You're saying how big would the mite be, not how big might it be. Yeah, it's this is the scale bar down here for this image. I was playing around earlier and got the scale bars on the screen correct. So let's while we're here and we're playing around with it, watch your eyes for a second. I'm going to change the microscope objective. I have dark field. Oh, it's a little bright. I need to make adjustments. You can see the mite stuck on its back. That's why it's not able to crawl around. It's laying on its back on the glass slide. It's like a turtle trying to get up. And it might actually look a little bit better at 5x. I don't know. Hang on. We'll see. Yeah, because you can see more of it in focus at the same time. And then if I zoom in, Now the scale bar is not quite right. Doesn't look great at 5x zoomed in. Looks okay at 10x zoomed in though. This is pretty amazing because I started off scraping off a stick that I found, 2 sticks that I found on the roof of my house. So I just stuck my arm out the window and grabbed them. Totally invisible, as Robert says. If you like microscope streams, I like microscope streams. They're my favorite kind. I do like some music streamers as well, and some art streamers, but the music ones and art ones are also cool, but there's not that many microscope people. So, look at this. I made a list for you. You can just add them all. They're all good. Pacific Plankton's here in the channel, and Del Maximum is going to come on in about
Good news,
a
everyone.
half hour, and then we're going to raid Del. OpenSet's another great microscope streamer. He plays keyboard while he does his microscope stuff. He does a bunch of psychedelic camera, virtual camera stuff on. Yeah. Check out Pacific Plankton. She's my favorite place to watch on Twitch. Well, her and Del are like they're my buddies. So I always hang out in their channels if I can. And then OpenSet, when he's on, sometimes he's like starts at midnight and I can't stay up that late. But when he's on during the day or picks a reasonable hour to show up, he plays keyboards and synthesizers and stuff while he's streaming. Spider ID's on in the mornings. He's got a stereo microscope and he looks at spiders and identifies them directly, immediately for people. I actually saw him do a outdoor stream the other day, which was cool. They went looking for spiders. Freckled Science, I think she's on right now. She was looking at bugs on a microscope earlier. Fazaria, she's a musician mostly, but she also streams, occasionally from the microscope. District 10 Mushrooms was here earlier. I don't know if District 10 is still here, but they do some microscope streaming as well, and they helped us identify our a fungus that was growing on the stick that we had. I put on the microscope. And then Line Wizard is another new streamer from a microscope, and A Tiny World is like the classic microscope streamer. And Protozoa Princess is an artist, and she also does a little bit of microscope streaming. Oh, you can see his mouth. It's moving its little mouth around. It's probably yelling out, "Somebody flip me over!" Sorry, we can't do that. Oh, the battery died. Did somebody catch the time? Did you set the poll for 10 minutes? Within 10 minutes. So, Pack, you're going to have to divvy out the money for whoever bit on it. And then Jolkson's another new streamer. He just plays music. I think it's a he, but maybe it's a she, or maybe it's a they. Who, they don't talk. They just do the microscope and then have music going on in the background. So I don't know what they look like or sound like. So no money. All right, I'm going to replace the battery. Does the house win? If you bet and lost, do I get the points? And you can go ahead and say yes, because I have infinite points in my channel, apparently. There we go. We're back at it. That's all that it took, and we already have this gorgeous little mite back on here crawling around. Poll is no points. Oh, prediction is the one for points. Yeah. Sorry. Forgot about that.
Good news, everyone.
All right, let's go back to DIC lighting. I gotta work to do to get it there. And then I put this big minus on my camera. Why is that so much brighter in mine? In the microscope, it kind of looks like this. Let's see. You can see a little bit more in the microscope. You can see those little tiny hairs on its butt. And it's maybe not that bright. It's kind of like this bright, though. You can still kind of see through it better than you can see through it here. There's no time at which the camera or the video is a substitute for actually looking through the microscope. As pretty as it looks for you, it looks even better in my microscope. I guarantee it to you. And its natural resolution on my screen in my eyes is much better than the screen that you're getting on Twitch. So, apologies for it always looking better for me than it does for you, but it will. Let's go to darker. This is a little bit sorry, not sorry, as they say.
Good news, everyone!
This side of the slide's already starting to dry up. So, you can see there's just a little halo of stuff around. That might actually be a little egg sac, or it could be a test amoeba. There's some stuff hanging out where there's water still. A lot of times when it starts to dry out, the things that need water, they'll try to scurry towards the places where there's water. There's a bunch of trichomes in here. It takes them a little bit for the water bears to dehydrate, so I think what I'm going to do is I'm just going to take the little bit that I had from before and I'm going to leave it on the stage. And I'm just going to add a little bit to it because I can sort of get to it. So, let's see. Can't reliably make either work. Will the light cook the bug? That's not a diatom, T-flow, or T-O-flow, whichever one it was. It is an LED light, and it does actually make the, it still actually can heat up the material, because regardless of whether it's an incandescent light or an LED light, it's still electromagnetic radiation and it has energy. So, yeah. I first thought the abstract images and the soothing voice would help me fall back asleep, and then all I do is fascinating, I think, get up and draw along. Are you drawing? Are you an artist, Shako? That's actually great. Pacific Plankton does that on her streams. Sometimes she draws what she sees. She's also an artist. And I have some sort of proclivities for art, but I don't try to draw while I'm streaming. That's a crazy idea. Somehow Pac makes it work, but takes all of my attention just to do this, so trying to do something else while I'm doing it seems like a ridiculous idea to me. So I just added some more to the one we already had. Hopefully that will double the amount of water bears we have in our sample, or tripled it. We did see one, but it was so sleepy, it hardly moved. So I'm hoping for another one. I'm being greedy. And then, depending on what happens, how soon that happens. Oh, look at this. My wish is my command. That's a water bear. Indeed. We're a little too close to it. There we go. See how it's like looking around, scouting around for food? There he goes. There's a water bear. Yep. Also, I promised Little Chook this. Hang on. Little Chook is one of my favorite artists on Twitch. And she's made a Instagram based on water bears, and she's making little clay water, I guess they're like Play-Doh or something, clay water bears, and glazing them, and then putting them in like different situations, and taking pictures of them and posting it to Instagram. And I think she's going to make it so you can buy, eventually you'll be able to go to a store and buy the little clay water bears. So I told her anytime I have a water bear on the screen, I would put that up there. Little Chook also drew for us Tardy B, which is like, yeah, water bear diorama. I don't have Tardy B on here anymore as a graphic. It was on the other computer, so I haven't added it back in. But she did have a little animated water bear that we had as a mascot for a while. So this is one of the bigger water bear types, and it's got sort of armor plating, the red or reddish brown kind. We see these regularly on that same type of tree branch. This one is confusing itself by sitting on something that's highly mobile and then trying to climb up it like a ding-dong. But they kind of look like caterpillars a little bit. There's a diatom right there. Off to the, where it's like walking right towards it. Yeah, the water bear's like got its face on the diatom right now. Oh, it's picked it up and moved it. It's batting it around. Oh, the horror. Let go. Let go of the water bear. Oh no. Well, it didn't eat it at least. It seems to have transferred it to a different foot now. It's so clumsy. It's just brutal. It's got that diatom stuck on a foot. That's not what you're supposed to do with diatoms. There's the diatom back there. It's still alive. Just barely, though. If it was a little bit smaller, the water bear could eat it. It's not snack size. There you go. Ding dong, yeah. It's a little ding dong. You sculpt. Oh, that's amazing. Hey Del, how you doing? We went from a stick to a water bear on stream. We made it happen. You saw me actually take the sample, scrape it into a bowl, add water, and then voila, magic happens. Water bears. We saw all the process, except for we didn't see it come to life. Sometimes I catch them as they're coming to life, but it sort of looked like the sleepy one that we had before. They just kind of move a little bit, and then they start moving a little bit more, and then they're awake. So, you never knew water bears were so translucent. Yeah, they are. Even the ones that are kind of armored, like this one, or red colored, are really pretty translucent. Some of them are really small and translucent as well. The water bear's right here for anybody who can't see it wiggling around. And those are the legs. They always have 8 legs. The back 2 legs are always together. And if you're wondering, did I find a water bear? Check to see how many legs it has, and if there are little claws on the end of the legs, that'll be a clue. So if you ever do, if you want to have a microscope and you want to replicate what, oh no, he's got the diatom again. You just can't leave it alone. If you ever want to know, is this a water bear? That's how you tell. Count the legs. They always have 8 legs. And then look for little claws at the ends of the legs. And they should have a newt on the front, a little snout. So, is that one really that size? Yes. We're accurate sizing right now. We're at the right size. You're seeing a scale bar that's correct. So, boop boop, water bear. Yeah. Let's see. Yeah, it's probably about 1/3 of a millimeter. Somewhere between 0.3 and 0.4, I would say. It's a good guess. Let's see, I could move it towards the scale bar. Yeah, maybe more like 2.5 to 3. Looks like a rotifer in the background. The poor bear is just like stuck on everything. Those claws, just they get trapped on everything that it touches. Where'd the sample come from? Marcel, this is the stick that we sampled right here. I took it off the roof of my house. Myself. And I used a knife and I just scraped the lichen into a bowl right here. I added some water from my sink. Are they stuck or is it a strategy? Oh, ask the water bear, I guess. Where'd he go? Start talking, lost the bear. Oh, I think I found him. He's just behind stuff. Let's see. What I should do, now that we've had a good look at this guy, is switch to dark field maybe. Watch your eyes. Uh-huh. One advantage of dark field is that the light's refracted, and instead of having stuff block our sight, we can actually sort of see a little bit better inside these lichen pieces. Newt newt. You can see the lichen here really clearly as well. That green stuff that's all around, that's cloudy looking. Those are pieces of the lichen that I shaved into the bowl and then used a pipette to pull out. Now it's really making things hard because it's on the other side of that, like 2 different piles of debris. I can still see it moving the debris back there, but it's like stuck in it. There we go. Kind of see it through there now. Hiding. An eyelash tool is what I need. I can move some of the bits out of the way. It might actually be a better strategy to look at these samples with dark field, because I think you can see a little bit better. Just saw something climb into this. I think maybe it's a nematode. Just keep seeing bits and pieces of it. Well, if it's gonna hide like this, let's go looking around, yeah? Let's see if we can find anything else in our sample. I know where we are, so I can come back to it if we have a chance. That's a rotifer. 1 leg. not 6. Oh, that's another water bear right there. It's
Good news, everyone.
It's a molt, or hang on. It's either a dead one or a molt. So let's go back to yeah, now you can see a little bit clearer now. I'm gonna tighten this thing. That was the analyzer plate. That's the outside of a water bear. The inside, I'm not sure what that is. It could be a dead water bear. I'm going the wrong direction. I should be going this way. There's a nematode. Another nematode. And another. We got rainbow colors. So we get to the edge of the water. It's just all diffracted around the edge. That's our dead rotifer. Or maybe a sleeping one. Big pile of goo. Another nematode and a rotifer. Looks pretty cool on the edge of the bubble with the light diffracting around it. Could I put a mustache on him? I can add a mustache for sure. I'll put a mustache GIF in over top of stuff, and then I can put a mustache on everything that way, including myself if I wanted to. I'll just add it to OBS, and then we can mustache things. If they sit still too long, there's some more nematodes. If they sit still too long, we'll just put a mustache on them, like as if we had Sharpies, right? And they're sleeping at a fret party in the 80s. We'll just mustache them. More nematodes. That's an old ciliate. Not sure what that is. Looks like a bit of the mite that we saw earlier, maybe. The molt of a mite. Mighty molt, if you will. I can't believe this thing is already drying out. I put like a lot of water on there. I think it's because of the fan, actually. I forgot about the fan. It's hot here, and we haven't turned on the air conditioning yet, so not hot enough for the air conditioning, not cold enough for a heater. But today was pretty toasty, so that was the mite that we saw earlier, right there. Still managing to crawl around. Kermit the Frog. Yeah, nematodes are pretty cool. Also can come right back to life too. Got a clip with it, mustache on something, that'll be great. Yeah. Oh, you're in DC, Robert? I used to live in DC. That was my my home when I worked at the USGS in the from like 97 to 2000, I lived in DC, where I became a fan of the Washington Capitals, who I still follow since then. It's a Roadfer. Go Caps. Nematodes just everywhere in this lichen. That is another water bear. I think maybe a dead one. They look like little, you know, they have that shape, right? There's the legs. Its back legs. I think that one's either dead or it's a molt. I think it's maybe dead. Could just be sleeping. It could be we need to take it to the farm. I think maybe it's dead though, yeah. Dirt nap. It's what I call a powered down nap. It may never power up again. It's having trouble powering up. It had less trouble powering down than it has powering up. Rotifer. Delloid rotifer. Speaking of Delloid, we must be getting close to 12 o'clock my time, which means that Del should be coming on soon if he's not already. He's not up yet. Sometimes it takes him a while. But my plan is to raid him when he starts, so I'm trying to coordinate it. Hey, there's the one that we found that was sleeping. It's still just hanging out there. It's so big. Oh my gosh. It's so big relative to the other ones we were looking at. It's like the mothership, isn't it? So that other one we saw was like, scale's correct. That other water bear we saw was 3/10 of a millimeter. And this one is easily twice as big, right? That's like 5 or 6 of those scale bars. You could almost see this one with your naked eye. Some of them are big enough that you can see with their naked eye. Right there is its head. It's moving its head around, but it's not moving much else. There, it's moving its arm a little bit. And it's one of its back legs back here, it's also twitching around. And it looks like there's still a nematode here. Effing with it. There's just like nematodes everywhere, but this one just keeps showing up and smacking it in the face. Like, come on. Come on. One time I saw a water bear like grab a nematode and it was like chewing on it. It had it half swallowed. So, if I were a nematode, I would reconsider that plan of action. This one's just a sleepy guy. Newt newt! It does have a big newt newt. Can you put a little water bear in the channel for that guy? Is there any way we could send them a message? I don't know, what kind of message would you like to send? I only have arrows and scale bars and diatom alerts. I don't know that I can send it any messages from there. That is just a big old water bear though. And it's sleepy. It's like, come on. I got this big. I made it this far. Let me sleep. Morse code. It's probably getting a little bit from the music playing, maybe. Fan's probably distorting it though. With the microscope light, yeah, let me see. I've got the diaphragm. I could twist that one. I've also got this diaphragm. I don't know that it felt that. Chillest water bearer in the world. It's pretty chill. It's sleeping with the lichen blanket, and you clipped the nematode slapping the rotifer. It's actually a water bear. But yeah. It was slapping it right in the face for a bit there. It's also been pushing it around. Here it comes again. It's like, come on. Come on. Move. People are watching. It does not care. Water bear, don't care. It's like, do your worst, nematode. I've had a day. Good vibrations. Alright. Well, we know that one's there. It's still there, I should say. We were going this way. Before the sample totally dries up. That one doesn't go anywhere, it just sits there, so we'll come back to it. In my streams from like earlier this year, I did some water bears streams. I don't know, it must have been like October or November, we did some streams with water bears. And I saved them on the slide. I just let it dry on the slide, and I labeled the slide and stuck it on my desk somewhere. And I still have some of those water bears. We named one Gubu, and we still have Gubu somewhere. And Tardy B was one that Little Chook drew, inspired Little Chook to start drawing water bears. And there's a nematode. Managing with the last little bit of water on this part of the slide. And I saved Tardy B as well. I have her on the slide somewhere, which means I should just be able to add some water and bring her back to life at any time. On demand. I think I still have those slides somewhere. My daughter was also helping us find some water bears. I had a little tiny microscope, and she found some. She found Gubu, actually. So we kept Gubu. And the other day she asked me if I still had Gubu. And I was like, oh yeah. She forgot the name of it. But she goes, oh, it starts with a G or something. She did remember that part. Sorry, I should probably zoom out so you can see what I'm doing. Water bear on demand. We haven't rehydrated them. They've actually just been sitting on the slides for a really long time. But water bears can go for quite a while without being rehydrated, so I think Gubu is probably fine. Maybe I will rehydrate Gubu though next week or something, and Tardy B, and we can revisit them. And I'll let Little Chook know what's happening. And then maybe I'll just have her join my Discord and hang out with us with Tardy B, and she can talk a little bit about her new Wawa Bears project. She's been making like a handwritten, they call it like a zine or something with them, and putting them in their diorama place things. I think this part of the slide is totally dried up, so we're not going to find anything moving. In fact, I thought I saw a water bear back here that was just dried up. It's on its way to pickling itself, as our sample is almost completely dried up over there. Nematodes are also clambering around. And the wet part of the slide over here is also starting to dry up, so there's another mite and nematode combination. A little rotifer. Can basic water bear, microscope see water bear? Yeah, any microscope. Mostly to see for hobby purposes, and in case my cat has some kind of parasites. Probably does. I don't want to spend too much, I know, so it's good to know basic microscopes can see these guys. Yeah, we're only at, our magnification right now is like 70 times. You don't need to have a really high-end microscope to see a water bear at all. So any basic microscope will be fine. If you wanted to stream it, or if you want DIC light or dark field or something like that, yeah, a fold scope will work. They don't cost hardly anything. They're like $5 or something. It's like a piece of cardboard with a lens made out of glue, basically. They'll work just fine. So water bears are not, they're hard to find sometimes, but they're not hard to see. So the trick is being patient. You know, like we looked at two, it's really starting to dry up. We looked at two big drops of water on one microscope slide, and we saw like 3 water bears and then some, you know, pieces. So keep in mind that you have to be very patient, and that's probably the hardest part, is being patient enough to go look for stuff and looking through the whole slide a couple of times, maybe 2 or 3 slides before you'll find one. So the densities are low. That's the hard part. And I put material over the entire slide, so it was a lot of volume of water, even though it dried up pretty quickly. But you have to be patient and look through the whole sample, or you're just gonna, I mean, if you expect to put it on there and see them right away, unless you know they're there, you probably aren't gonna find them. Very low likelihood of you finding them immediately. So you have to be patient. It's a bit of a hunt. It also helps if you actually use lower magnification. So in the patience is a virtue. In the fall when I was doing it, I only had my 20x objective and my 40x objective. I didn't have a 10x objective yet, because I'm used to looking at diatoms under super high power, and I didn't have a reason for a 10x objective or a 5x objective like I have on this one. So it was actually made it harder to find when zoomed in that closely, because I had to look through so much material in order to find them. Even though you think, oh, bigger magnification's better, it often isn't, unless you're looking for something very small. Magnification's not going to help. It's going to make it harder because you're too zoomed in. Yeah, and then you might spend an hour going across the slide looking for water bear, but if you had a 10x, you'd be able to see them. And yeah, diatoms are very small, so I need to have high-end microscopes, but definitely don't need them for the little guys, for the water bears and rotifers and the things that we look at on here for living material. Usually it's fine. So that's what always happens. I expect Dell to start right at midnight, because he usually is pretty good about it, and then whenever I'm waiting for him, he always takes a lot longer. He's got, you know, a daughter to manage, so it's not like he's opting to hang out and be slow. But he is late. It's 10 minutes past midnight, Del. Get your act together. Nice part is I still have a lot of sample here we can add. And all it's going to do is make more water bears for us to see, so... Oop, something's moving around. It's awfully big. I think it's just a floater. That's a rotifer, and that's a nematode. And that little thing right there looks a lot like a water bear egg. You've got big diatoms. Always bragging about the size of your diatoms. Yeah. That looks like a water bear egg to me. This is the shape they have for some of them. Definitely looks like an egg, doesn't it? But you are sending me samples, so I also have big diatoms sometimes. So I forgot, I might be able to stream from the SEM on Saturday, because I think the Spirit University people, where I'm doing my Dr. Mo stuff, usually we do something on Saturday, and I think this week it's going to be on Sunday, and I think we're going to play a game together, all four of us, with our VTube characters, and I might end up streaming my part. I'm not sure, depends on what game we play, on Twitch. So if you're not familiar with my Dr. Mo VTube character, he gives science lectures on YouTube. But I think we're going to try to do a team game. Terraria or Valheim or something like that, where we can all play as our characters for like a funsy stream. And so my Saturday's open, and my classes are all done, and so I don't have to put any lectures together or anything over the weekend, so I may just play, and you may see me on the SEM on Saturday as a result, which I told you I wasn't going to do for a while, but then immediately did, so ignore whatever I said I was going to do, like stream on Mondays and not Saturdays. So but I think it's just for this week. I don't know if that's going to be a regular thing or what's going to happen. So for now, who knows? Worms, rotifers. Some floaters going by. There's another rotifer. There's like a raft up here, lichen raft floating on the surface of my water. That's what's causing all the shadows. Nematode's got a bit of junk on it. Yeah, it's vibing. let's see. I'm going to oops. It looks like Dell has turned on his equipment. I'm waiting to see if he's actually got a start screen or what's going on, because I don't want to send you to a start screen. Yeah, he's still on the start screen. So we'll go raid Dell in about a minute or two whenever he finishes getting set up at his house. And he's promised me that he's going to at least start off with some more microscope stuff. So we'll go from microscope stream to microscope stream, which is my favorite. And I have this dream that one day we will put together a whole day of microscope streaming with a raid train sort of system where we go from one streamer to the next. Either a 12-hour version or a 24-hour version where we could feature all of the different microscope streamers like in one day. There's our water bear, the big one. She's still just hanging out, holding on. She's still moving. You can see her head's moving up here a little bit still. Yeah, continuous microscope experience. So if it was like a Wednesday or a Thursday, a Monday, we just need to set it up a little bit, you know, so that everybody could be involved that wants to be. And she's still here. She's still hanging out and she's still sleeping. She don't care. And this one's still dead and still sitting there. Free the water bear. Oh, she's free. She's just sleeping. She's more like Cthulhu. She's free, but the sleeper is not awake. And when she wakes up, it might be the end for all of us, so maybe we want her to stay asleep. Maybe we found the Cthulhu bear, and we're better off with her sleeping. You never know. Something big just swam through. Here it is. Came in with my pond sample, I think. It's in here looking for food. Some sort of very large protozoan. I think that in the middle is, right here, is a testate amoeba, which we followed around a lot yesterday. Snorlax, the bear. Yeah, Dell is up. Yeah, I think that's actually a testate amoeba that's alive. I see its pseudopods moving very slowly. Okay, well, if Dell is live and Dell is live, then we can jump over to Dell, and that would be great because I've been streaming for like over 2 hours. How long have I been streaming? Like a while, right? I don't know what my uptime is. Yeah, okay. But let's go get Dell. And I want to say thanks to everybody for hanging out with us again. Dell is also one of my favorite streamers to watch. He does a bunch of stuff on microscopes. 2 hours and 48 minutes. When will this microscope game be on the VR? I don't know. I wish I had a microscope game that we could play. I don't know how to make games anymore. I used to a long time ago. It's been a fun stream, and as always, The SEM stream was fun earlier today. The light microscope streams are fun. They're always calm and, pretty laid back, watching weird organisms, and plenty of time on the microscope. We saw some diatoms. We got to see some water bears, rotifers, and nematodes, a mite. We saw some, little mite crawling around. It's been a good day. Got a lot. So let's go get Del. Let's see what he's up to on his microscope. And I want to thank everybody again for hanging out. It's always fun. And I've been streaming a lot recently, especially in the evenings. I want to say thank you to the people who followed me today. That's JR Carlos 21, Little Guys TV, Peppercat 8, also for chit-chatting with us, Peppercat, thank you. Mezcel also chatted and followed. Shaco 2T took some clips and hung out and chat with us. Metal Luna John, Stackus, and Tarkanite, and Mad Kiwi, New Zealand 1, 325, also with a follow, Paso Preto, Anuska Patella, Samsung was in here. They've been very generous. They've been gifting subs to people, and they gifted a sub to Del Maximum, so thank you for that. And that's it. Although we did have somebody named Lemon who followed me before the stream started, so also thank you for following, Lemon. We are 4 followers away from 1,700, and last week we were almost to 1,600, so we've picked up almost 100 followers this week. It's been a good week. A lot of streaming probably helps that. When I'm done with the sample, I'm going to put all of my water bears in the... I have like a little water bear farm here, basically, so I will keep it around. It will not die, unless it dies naturally. And other than that, let's go raid Del Maximum. For anybody who... Oh no! Vika Victor is raiding with Party 10. Right as we're getting ready to raid Del. So we're going to just carry you right on over to Del Maximum stream. For anybody who's coming in at the last minute here, I've been streaming for like almost 3 hours from the light microscope. We've seen a bunch of really cool stuff.
Good news, everyone!
Say thank you a lot for the raid. Just a little awkward, came in right at the end. It's the Tick! Spoon!
Good news, everyone!
I am the evil mad bomber, what bombs at midnight, and it's the end of my stream. So,
good news, everyone!
Thank you for all the follows. Guys, I'm now like 1 follower from 1,700 because I just counted 3 more, right?
Good news, everyone!
Hey, that's it. Starlight, you did. Oh no, Baby Corn, you did it. You made us 1,700 followers.
Good news, everyone!
We're looking right now at a nematode. We're getting ready to raid, though. So you came in, you're going to get dumped into Del Maximum. So if you're hoping for a microscope raid, the good thing is
good news, everyone!
We're going to another microscope raid, another microscope place. So just get your raid emotes, keep them coming, and we'll just go straight into Del stream with even more people. That'll be great. Thank you for all the follows, and we'll catch you next time. Here we go. Get the raid.
There's the gang. Diatoms attack. Why, hello there. Raiders,
this is time to rock and roll.
Welcome. How was
Bring
the time?
the noise.
Just came back from Diatoms attack. Comfy stream. Looking at all kinds of neat stuff. So I've got my microscope software up. Tonight is not a crazy microscope. Like
Little hands, this
last
is time
stream I
to rock
spent
and
3
roll.
hours on the microscope.
Bring the
Tonight we're playing
noise.